All right, in this question, we'll be considering a centuries-old problem. Leonardo da Vinci proposed a flying machine that would work like a screw to lift the pilot into the air. The screw is rotated by the pilot. The machine and the pilot together have a total mass of 120 kilograms. Which useful output power must the pilot provide to move vertically upwards at a constant speed of 2.5 meters per second? So all of our answers are in watts here. I might say it's probably D, just because it seems like it would take a lot of energy to do that. If we could, do it with less, then this might actually work. So let's do the calculation. So in order to move vertically upwards, you have to supply a force that is equal to the weight. And so mass isn't weight. We saw earlier in class today how weight is equal to mass times the acceleration due to gravity. And so a useful thing might be to calculate what that weight is. And so we've got 120 kilograms, 9.81 newtons per kilogram here on Earth. Again, that's the same thing as meters per second squared, right? The acceleration of free fall, or newtons per kilogram. So 120 times 9.81. 1177.2 newtons. So that's the force that we need to supply. Okay, now this is asking about power. And so power, you may recall, is the rate of change of work. So it's like the rate at which work is done. Because work and energy are really the same thing, we could think about power as the rate that one form of energy is converted into another. You can kind of think about this as converting kinetic energy into gravitational potential energy, right? So they're moving this around, and that is going to lift them up. And so that's sort of converting energy into potential energy, right? So that's sort of an energy conversion that's occurring. And if we think sort of more about work over time and work as force times displacement, you may recall that work is accomplished when we apply a force in the direction of displacement. Right, so the component of force that acts in the direction of displacement times the displacement, that's the definition of work. And so work over time, we could substitute in displacement over time is velocity, right? So we have this equivalent sort of definition for power. And indeed, as you become more and more familiar with the physics, you read a question like this and you say, okay, I'm given a velocity and I'm asked to solve for power. And most students will immediately sort of go to this form of power. They would say, well, the useful thing here is going to be power equals force times velocity. The force that I need to supply is equal to the weight. The velocity was given. And so it should just be the product of these two numbers, the 1177.2 newtons. That's how much that 120 kilograms weighs on Earth, multiplied by 2.5 meters every second. And so it's kind of like Newton meters per 1 second, right? So a Newton meter is a joule per second is a watt. So the units always work out. And so this is your path to the solution. You get a power of 2943 watts, which is about 2,900 watts. And so your instinct or your intuition serves you well if you just think, well, it must be a lot of power to get a human to go on that flying machine. So almost 3 kilowatts of power would be needed.